Black holes are the strangest objects in the universe. Their gravity is so strong that nothing, not even light, can escape. If you fell toward one, time would slow, your body would stretch, and the laws of physics would begin to break down. So, what exactly would happen if a person crossed the edge of a black hole? Let's explore this terrifying journey step by step. The mysterious nature of black holes. Black holes are among the most mysterious objects in the universe. At their core, they are regions where gravity is so intense that nothing, not even light, can escape. They are born from the deaths of massive stars. When such a star runs out of fuel, it can no longer fight against the pull of its own gravity. The core collapses, compressing matter into an unimaginably small and dense point. This collapse gives birth to a black hole. The edge of a black hole is called the event horizon. It isn't a physical surface, but an invisible boundary. Once something crosses this line, whether it's a spacecraft, a planet, or even a beam of light, there is no way back. The event horizon is the ultimate point of no return. Black holes come in different sizes. Some are stellar mass black holes, only a few times heavier than our sun. Others are supermassive, containing millions or even billions of solar masses, lurking at the centers of galaxies. Despite their size differences, they share one terrifying trait. Their escape velocity exceeds the speed of light. So, what would happen if you drifted too close to one of these cosmic monsters? That's where the nightmare begins. Approaching the event horizon. As you drift nearer, gravity begins to bend everything you see. Stars behind the black hole appear twisted and smeared, their light stretched into glowing arcs that wrap around the darkness. The sky itself looks distorted, as though you're peering through warped glass. From far away, an observer watching your descent would notice something strange. As you get closer to the event horizon, your motion appears slower and slower. To them, you would seem to freeze on the edge, fading into blackness but never quite falling in. But for you, inside this pull, time feels normal. Seconds tick by naturally, your heart beats steady, your fall unstoppable. The outside world, however, looks accelerated, as if the universe itself is racing forward while you continue to sink deeper. Right in front of you is the invisible boundary, the event horizon. Beyond it, escape is impossible. This is the threshold where the real nightmare begins. The event horizon, point of no return. The event horizon is the most defining feature of a black hole. It isn't a solid surface, but an invisible line where gravity grows so powerful that the escape velocity is faster than the speed of light. Once anything crosses this line, whether a particle, a spaceship, or even light itself, it can never return. To the rest of the universe, you simply vanish. Inside, the journey becomes even more frightening. As you pass through the horizon, the normal rules of space and time no longer behave the way we understand them. There is no turning back, no pause, no escape. Every step pulls you deeper, dragging you further into the darkness. Physics itself begins to collapse, and the universe outside loses its meaning for you. You are cut off, trapped in a one-way passage with only one possible outcome. And in that terrible descent, you would soon encounter one of the strangest and most horrifying effects of all: spaghettification. Spaghettification. Once you fall past the event horizon, the real nightmare begins. This is where tidal forces take control. Gravity isn't equal across your body. The black hole pulls more strongly on the part of you that's closer to it, usually your feet, while your head, slightly farther away, feels a weaker tug. That difference in pull grows so extreme that it begins to stretch you apart, just like a piece of spaghetti. In smaller black holes, this deadly stretching happens even before you cross the horizon. The gravitational gradient is so sharp that no suit or structure could hold you together. Your body would be pulled long and thin in a fraction of a second. For supermassive black holes, the story is different. Because their horizons are so vast, the gradient near the edge is gentler. You might cross over without noticing immediate harm, drifting deeper into the abyss. But the farther you fall, the stronger the pull becomes until even atoms themselves are ripped apart. Imagine Chase falling feet first. At first, he feels the tug, like invisible hands pulling harder at his legs. Then the pressure grows unbearable. His body stretches longer, thinner, until he becomes a noodle of matter spiraling into darkness. And while his body is torn apart, something even stranger is happening to time itself. Time dilation and the outside view. As you fall toward a black hole, one of the strangest effects you'll encounter is time dilation. From the perspective of Earth or any distant observer, your journey slows dramatically. To them, it looks as though you are moving in slow motion as you approach the event horizon. Just before you reach the boundary, you would appear to freeze completely, stuck on the edge forever, your image fading into red light and eventually disappearing. But for you, inside the fall, nothing feels unusual. Seconds pass as they always do. Your heartbeat continues, your thoughts flow, and your descent is steady. Time feels perfectly normal to you. The real distortion comes from how you perceive the outside universe. To your eyes, the cosmos beyond the black hole seems to accelerate. Stars race across the sky, galaxies shift and move, and entire ages of the universe unfold in moments. This means that, in theory, a person falling into a black hole could watch the far future of the cosmos play out. Civilizations could rise and vanish, galaxies could collide, and the night sky could change beyond recognition, all while you continue to fall. But this astonishing view doesn't last forever. Once you pass deeper, there's no more connection to the outside. What lies beyond that horizon is even more mysterious. Inside the black hole, crossing the event horizon is like stepping into a reality where the rules of physics no longer apply. Inside, space and time begin to behave in ways that defy everything we know. Movement forward is no longer an option. Instead, every direction, no matter where you try to go, bends inward. It's as if the entire universe is a funnel, and you are sliding down with no way to climb back. At the very heart of this cosmic monster lies the Singularity. This is not a place in the usual sense. It's a point where matter is crushed into infinite density, where space is curved infinitely, and time itself ceases to exist as we understand it. Our current science simply breaks down here. The laws of physics that work everywhere else in the universe no longer make sense. What happens if you reach the Singularity? No one knows for sure. Some theories suggest that you would be destroyed, stretched into nothingness by the unimaginable forces. Other ideas whisper about wormholes, alternate realities, or new universes on the other side. These remain speculations, but they show how mysterious black holes truly are. And while the physics stuns us, the bigger question is what all of this means for our place in the cosmos. We followed the journey step by step, from the moment you approached a black hole, to the terrifying pull of the event horizon, the unimaginable stretching of spaghettification, the strange slowdown of time, and finally, the mystery of the Singularity. Each stage shows us that falling into a black hole is not just a dangerous trip, but a one-way passage into the unknown. Black holes are both terrifying and fascinating. They remind us how fragile human life is against the raw power of the universe, yet they also invite us to wonder. These cosmic giants challenge our deepest understanding of space, time, and physics itself. They stand as reminders that there are still secrets out there waiting to be uncovered. We may never send a human into a black hole and see them return, but by studying them from a distance, we get glimpses of truths that could reshape how we view reality. And here's the final thought. If a single black hole can tear us apart, what happens when two of them collide? The answer is even stranger than you think. If you enjoyed this journey, make sure to like, share, and subscribe for more deep dive science stories.